I know it's late on a Friday afternoon and we probably should be sitting in this session with some beers, but what I want to do is spend the next hour talking about a bit of a personal journey that I've been on over the last 4 years. But I want to start with an experiment. And this is really a test to see how we are humans in comparison to machines. So anyone in the room tell me what this is? Yell it out if you know. Opera House. So the computer thinks that that's a close-up of a water fountain, and it thinks that with very low confidence. Now, still the Opera House, right? Picture containing sky. And it should be clear to everybody in the room that this is the iconic building down on Sydney's harbour. The computer sees this as a large white building with high confidence, which technically is correct. Now, what was going on there is the context of that image was relevant to a lot of the people in the room. How many of the people who called out Opera House live here in Sydney? Yeah, so most. So you're used to seeing this building and you're used to seeing it inside of this context. So even when you don't have all the information, you can still make the assumption that that's what you're looking at and that is the building that you see. Now, to get the machine to identify that as the Sydney Opera House should be relatively easy because it's pretty iconic, it's got the shell shapes, and it's something that you might instantly recognize. But it turns out it's not as easy a problem as you might think. So I'm just going to show you an example here. This is a custom vision AI. So this is an API that's been released by Microsoft that enables you to take a base trained solution. So this has been trained on landscapes and buildings, and then enhance it with additional information. So what I've done here is actually upload a bunch of images of shell-shaped buildings, including the Sydney Opera House and the Lotus building in India, as well as the Science and Innovation Centre in Singapore. And what I've done is I've tagged this based on the particular building that you're seeing. So this is the Science and Technology building in Singapore. This here is the Sydney Opera House. Oh, sorry, if I unselect that one. And I've also shown variation when it's been during the Light Festival in Vivid, and when you can see it when it's just the building that's here. And then over here are buildings that are shaped like a lotus. So if you didn't have the context of knowing Sydney, knowing the Opera House, a lot of these structures would look quite similar to each other. And to give you an example of how you might test that, you could load an image that the model hasn't seen before. So here's the image we trained of the Sydney Opera House. Now, it hasn't seen this particular photo, but it's been trained on photos that are similar. And if I scroll down here, you'll notice that, didn't want to zoom in, but you'll see it's 100% sure that it's a building, it's 100% sure that it's a shell-shaped building, and it's 99.9% sure it's seen the Opera House. And then if I show it another variation of that, maybe this photo here, which is a little bit more difficult to recognize. Now this photo is a close-up of the Opera House with the Harbour Bridge in the background that I took yesterday morning. And when it's looking at this image, it's also identifying what it sees in the image. So if I just see down here, it's identifying a shell-shaped building and again the Opera House. Now that's pretty hard to do because that image there looks very different to, say, the iconic version that I showed you at the start of the talk. And if I look at some of the other predictions that have been made, I've shown it photos that it hasn't seen before, a version of the Opera House that's made out of Lego world, and you'll see that it's identified that as the Opera House. Here it is during Vivid, so it sees it as Vivid. Here's a building that is similar to the Opera House, but not the Opera House. And you see that is identified as a shell building, but not the Opera House. Change the belt pack. Okay, sorry. Thanks. So the reason I'm showing you this is I want to introduce to you this concept of how the machines, learn to think. So if you haven't seen that before, that is how the deep learning is advancing to such a point that it can be used inside of an autonomous vehicle to drive and to make decisions on the road. That is the YOLO deep learning library, which has an extension which enables you to run that kind of speed for deep learning on a mobile device. So the example I showed earlier transitions right out to that concept of having the machines think and interact and recognize things in our world. So when we think about humans plus machines, humans have understanding, purpose, and passion, and machines have calculations, instructions, and objectivity. So when we put those together, a novice plus a machine and a better process can exceed beyond an expert plus a machine plus an inferior process. So these two guys here, the year was 2005, and Zach Stephen and Stephen Crampton were two novice chess players. They had amateur ranking in the world chess rankings. And they entered a competition which was the first time machines could be used with people to play a game of chess. And their approach of humans plus machines beat out the best supercomputers in the world. It also beat out the best grandmasters in the world. Because what they did is they augmented their intelligence using some processing on 3 simple IBM PCs. This here, anyone familiar with Kaggle.com? So a couple of hands. Jennifer talked about this briefly in her keynote at the start of NDC. And what Kaggle.com is it's really a platform for people to experiment and work together to solve AI or machine learning problems. And the great thing about the community is that companies will put the data down there, put the problems they want solved, and then they'll offer prize money to those people who can solve it. And because the solutions happen out in the open, you can learn from each other, you can learn from others, and then you can apply different techniques to solve the particular problems that you face. So a few years ago, I think it was about 4 years ago, I was standing up on a stage not that dissimilar to this. And I was talking about data is the new oil, AI is the new electricity. And I felt like a real fraud because I actually didn't have my own big data set, my own experience, and my own story that attached itself to data. At the same time, I was a bit overweight, and I was starting to suffer from vertigo from sitting in front of my computer for 10 years programming, tapping on the keyboard. And I realized that when I went to see what was wrong with me, I went through all the medical checks, I got a scan, I went through the doctors, and they couldn't really say anything was wrong. They said you were all fine. And then I went and saw a physio who said, your problem is lack of activity, bad posture, crunching over a computer. And that for me made me aware that I had to change, and I had to change my behavior to fix the problem because it had been going on for a few months. Now, change in itself, something stops, change happens, then something begins. But I like to think about it like this, and this is the change formula, the formula for change. Dissatisfaction with the current state, times by the vision of what you want to achieve, times by the first steps required to get there. As long as that is greater than the resistance that you apply on yourself, change will occur. So starting with dissatisfaction, my love of craft beer plus my lack of activity was leading to my state of dissatisfaction. The vision of what I wanted to achieve, I set myself an impossible goal, something that I never thought I was going to be able to do. I said I was going to run 4,000 kilometers in 2014. And this was near the end of 2013 when I set this goal. I was unfit. I had no understanding or comprehension about how I was going to achieve that. And then I went on, I achieved that goal. I did 4,041 kilometers that year. And you'll notice I still had quite a high intake on the beers. And then 2015, I set myself 5,000 kilometer goal, and I achieved that as well, 5,100. 2016, I set myself a different goal. I didn't want to go for the 6,000 Ks, but I did say I was going to run an ultramarathon. And I did my first ultramarathon in 8 hours and 22 minutes for 67 kilometers. And when I wind that back to that vision, I went back to my first steps. And my first steps were to get a treadmill. I got a standing desk and a treadmill so that when I was programming throughout the day, I was standing up and I was programming while I could walk, and I could switch between walking and sitting, and I could start to move. Now, I couldn't run 1 kilometre on the treadmill at that time. I had a really high resting heart rate, and I was generally very unfit. But that was how I kind of put that formula together to drive towards the change. Now, in any hero story, if you've seen Star Wars, you know everything's going, the training's going well, you're on the path to becoming the Jedi, and then resistance happens, or something happens that changes and takes you back to your previous state. For me, resistance came in the form of a virus. I became allergic to exercise. So what happened was I was running towards this goal of 4,000 kilometers a year in 2014, and I started to get sick, and I got a virus, but I didn't want to stop, because if I'd stopped exercising, I kind of was going to lose against my goal and not make the outcome I was driving towards. So I kept running when I had the virus, and off the back of the virus, I conducted an immune disease with no known cause and no known cure. It literally meant that when I sweated, I broke out in full-body hives and couldn't continue exercising. And that disease has a name. It was called chronic urticaria. It's probably something that many people have not heard of. It was something I certainly hadn't heard of. I had to do some research and understand what it all meant. But what it was is that my immune system in my body had incorrectly identified exercise as something to attack, as the virus itself that I had at the time while I was exercising. And I cured myself through insight from data. And this is where the story gets kind of interesting, and I wanted to share some steps on how I did that. So the first thing, track everything. So I don't know if you've seen Adam Kogan here at the conference. He spoke on Visual Studio on day 1. I noticed he's wearing 4 wearable devices, 2 on each wrist, that he's been tracking and correlating his data. Now, I say that this is a little bit extreme. I wear a single device, and I've changed the device over the years as well. So my journey started with a Fitbit 1 back in 2012. I went to a Band, I went to a Surge, a Microsoft Band 2, and now I'm on a Garmin Fenix HR device, which is my main wearable device. And when I come back to the tracking, so that enables you to get access to the information and the data that you've got. One thing I will say on this is be careful around the ecosystem that you buy into. I found Fitbit was somewhat closed and that you had to pay to get access to your data. Other platforms make it more difficult to access data. I'll show you the examples later where I'm using Garmin, and it's very easy to get your data out. The next part, learn how to breathe. Who knew that you had to learn how to breathe? I had no idea. You never taught it at school, but I went and saw a guy called Dr. Sven at the Resilience Institute in Auckland, and he introduced me to this concept called heart maths. And it's really around slowing your breathing and adjusting your breathing to move from this chaos state to this coherent state, and adjusting the settlement in your brain. And after I learnt that technique, it turned out that that same technique could be used on an ECG machine to adjust attention and meditation, and able to create the machine to move things forward, to move things left. It gave you mind control as well as body control. And so what I also learned when I went through this process is that I had a really high elevated resting heart rate. And my resting heart rate was kind of made worse by my diet and my physical makeup. So the next part was learn how to eat. So if you look at this little chart here, up here on the left is when I conducted the virus. Over here is the period that I had chronic urticaria. Just up here was when I changed my diet, and then 30 days later was when I was cured. And what I did to change the diet is I treated it like an experiment. I took all of the foods and things that I was eating, and I reset. I went back to just raw, whole foods, vegan kind of diet, and then I reintroduced things one by one and measured the effect of reintroducing those things, like you would if you were working on an experiment in science at school. And what I found out was that my body had a really negative effect on caffeine. And that was made worse with the amount of coffee I was drinking and also the alcohol. So when I had caffeine, I had a higher resting heart rate for a longer period of time. And what I was able to do then was identify by removing caffeine, I was getting a better body state. And I also found that, as I added things back in, if my ears went red or if I had kind of physical outcomes from the foods that were coming back, I would reduce them. So doing things like moving to almond milk in the morning and stuff like that. And so from there, I kind of had a base set of what the different aspects meant to my body. And when I think about what was going on with the data, we're moving from a world of knowing what happened and why it happened to moving to a world of predicting what is going to happen and what is needed to make it happen. I really like this graph here from Gartner, where it talks about hindsight. So traditional business intelligence is about hindsight. It's about having a descriptive analytics of what happened. It's about understanding why it happened. And then we're moving to this world of advanced analytics. So when we think about advanced analytics, this is insight. This is predicting what is going to happen and how we can make it happen. So in some cases, when you know what's going to happen, you want to change behavior to avoid it happening, or you want to encourage it to happen and to actually change behavior to make it happen. And this is really the area of advanced analytics that we're moving towards, and it's what I wanted to demonstrate and show you in the next examples. How many people here are on Strava or familiar with Strava? Wow, half the room. So Strava is the social network for runners and cyclists. It's a place where you can extract data from wearable devices, and it can be plotted inside of this Strava platform. And what this is here is, this is the fitness and freshness graph, which shows increase in fitness over time, peaking and dropping based on well-being from your physical device. And this is fantastic because I follow this when I'm training for a race or when I'm actually developing and building my fitness up. So you see when I started, I wasn't very fit. And then I kind of moved up that mountain and then dropped down and drop along and move along as we are. And this is where I am today. I just took this screenshot earlier today. And this is my bot. And I'm going to talk a little bit about this bot and show you how it's been built and how the pieces come together. But what it does now is, if you look over on the left-hand side, it'll send me an SMS when it predicts that I'm going to get a virus, or when I'm starting to get sick, or if I'm getting stressed and I need to slow down. So you'll see some push notices up here where it's saying on July the 2nd, it predicted that I wasn't sick with 63% confidence. The reason I got that one to push is because this confidence is going down. So that's sometimes a sign that I'm starting to fight a virus, or that I'm starting to have some challenges with stress. In that case, it was actually the stress of a reorg at Microsoft that was going on that pushed me into that state. The next one down here, it was predicting that I was sick with 86% confidence. Now, that actually was a false positive because I'd traveled to Las Vegas and I'd run in the heat, and I just got off the plane and I was jet lagged and ran in the heat in Las Vegas. So that wasn't positive examples, and I was thinking of ways to actually get more data points to massage that one out. But I'm going to show you a little bit about this whole platform of what I've built and how I've built it and how the pieces come together, so that you can. I've also published this on GitHub, so you could kind of pick it up and take it for yourself and maybe think about some of the components to it. Now, I use this as a bit of a learning project. I chose Node because I didn't know how to program in Node. I'd been working in C# and I wanted to learn. And I also picked up some of the other components that I was looking to get experience in. I notice here it still says Azure Search. I did use Azure Search originally, Elasticsearch, but then I stopped using that and started going directly back to the document database. But what I want to do is show you how the components come together. So I'm going to come back over here now. And this is the GitHub repository, and I'll share the links a little bit later on in the talk. But the first component is actually an Azure function. Now, what the Azure function does is it connects every, I think it's, what have I got it running? I think I've got it running every half hour maybe once on the hour, once every hour to the Garmin device, and it pulls the data that comes off my wristwatch once an hour. So this is constantly syncing over Bluetooth to my phone, and once an hour it's updating into my document database. I'm also going out to my Fitbit scales, which are synced through my Fitness Pal into my Garmin, and it's getting my weight once a day. And I use a platform called Untapped. Anyone familiar with Untapped? There's a few. So it's the social network for beer. It's like Strava, but for beer. And that's the only thing I actually physically have to do, which is check in my beers when I drink them through this app. And then that gets my beer consumption into the mix as well. And so what this does is it calls it takes the data out, it gets the information, and then it calls the Azure Machine Learning to determine, make a prediction as to if I'm getting sick or if there's some anomalies in my data. And I'll get into that a little bit. And then it writes it into a document database. So over here, I've got the document database. And if I look at the overview of this database, for those who aren't familiar, Cosmos DB is Microsoft's, I guess it's globally distributed low latency document database. And so I could turn on endpoints in all these different regions around the world, and it would guarantee less than 10 millisecond latency for the person from the location closest to their data center. Right now, I've just got it replicating in the west coast of the US. And down here, this is the number of requests that are kind of coming into the database. It's got a nice feature, which is Data Explorer, where you can look at the information coming into the database. So if I look in the documents over here and look at the latest document, that's Saturday, 27th of the 5th. If I edit this and I say I think I've got a copy there. So I can do an order by c.date logged descending. So it's kind of like an OData query language. And if I look at that one there, that's today. So this is today's data coming through over here. And you'll see for today, today, Friday, quite a number of steps, quite a big distance, and a reasonable amount of activity as well. Whoa, max heart rate 222? Jeez, that's not good. Don't question the data. And then what that's doing is that's creating sort of this daily information that I don't really have to think about, that's just automatically been pulled out and pushed into this database. If you're familiar with using Power BI, Power BI has got a beta data connector here, which if you go to Azure, and there's Azure Document DB in beta, so you can connect this directly to this kind of document database or Cosmos DB. And then you can create these visualization experiences. So what I've done is I've created some sample Power BI reports, and then I've published those up on the GitHub page as well. And if you look over on the right-hand side, you'll notice that if you see the page information, the size here is for Cortana. And that's because I've turned on Cortana Integration. So the way that you can do that, if you haven't used Power BI before, is over in Power BI, you upload your data source, and you can, under Schedule Refresh, you can choose how often it refreshes from your data. So over here, it's connected to my document DB, and I'm refreshing that once every 3 hours, and that updates the data source. And then I've turned on this thing called Q&A Cortana, which allows Cortana to access the data set. And I've got some featured Q&A questions, so I can prompt to know what sort of questions I can ask of my data. So if I come down here, I could then say beers 2014, for example. I think that, and there it comes up here. And this is going to show me how many beers I had in 2014. It will show it by month. It shows me my weight over the time as well, so you can see my weight adjusting based on my beer consumption. I had a lot of beers in May. My weight dropped up in June a little bit. And you notice that this is the period in the graph where I actually did my full reset. So that's September, and then October I didn't drink anything because I was doing my reset for that 30 days, so that's kind of where that sits there. Also breaks it out, so you notice that's the day of the week. Saturday seems to have more beer than during the week. I can say, okay, well, distance travelled, 2014, and that will show the distance I went in 2014. So you'll see up here, that's the 4,042 kilometres, broken out by month with particular activity days kind of down on the bottom there. So you can find pretty quickly insight from the data and the information itself. I think the last one I wanted to show is heart rate 2016. So see heart rate 2016. And what that's showing there is kind of interesting, because that's showing, like, on Saturday, I've got a lot more activity. So I do a lot of my running or my distance running on Saturday. And as a result, I have a higher, it affects the heart rate a little bit on that day as well. So I kind of get that idea about fitness and form, which is this one here, and the minimum heart rate, maximum heart rate, and the weight change and fluctuation during that time as well. If I come into here and go into my favorites area, this is the dashboard where I can ask questions of my data. So I could say, what was my average sleep in 2017 by month? And that's kind of gone down and said, well, 2017, you've got your most sleep in January, averaging 9 hours sleep in January. I don't know why that was, but that's a lot. But as the year's gone on, you'll notice that I'm actually having the least sleep at the moment in August on average. And if I said, instead of in 2017, I could say by month, by year. Try that one. And that should work. Yeah, there we go. And that's now telling me that, 2016, January, I slept a lot less than I did in January this year. So you can kind of get that fluctuation by month, by year. So you can really start to find some pretty interesting data come out. There's a good feature in here as well, which is where it analyzes your data for you and it creates some insights. So you can come over to your data set and go view insights. And what that does is it looks through your data and it looks for stuff. It looks for anomalies. It looks for things that you may not know. So it's saying 2006, relatively steady % of lowest heart rate. But there's also saying there's some outliers. Now, this is what got me thinking about where I might find some of the signals around what getting sick looks like or what getting stressed looks like. Because I realized in some of the places I was finding outliers, I was also finding that I was sick around those times as well. And if you go down further, correlating sleep and beers, correlation between sleep and beers, who would have thought? So the more beers you have has an effect on sleep and sleep patterns. This is another one, calories burned is trending downwards. Okay, I'm not doing as much exercise as I was when I was kind of crazy. And you can start to get a bit of information that comes out of that kind of thing. Now, if I come over to the machine learning part of this, if you think back to Jennifer's session at the start of the conference in the keynote, she talked about creating a binary classifier for identifying if her husband was lying or not, or if someone was lying or not. What I've done here is I've looked inside of all my data and I've marked the days that I was sick, and that's kind of my supervised learning. So that's my labeled data for where I'm identifying whether I'm sick or not. And by taking that data set and putting that label on it, I'm then able to bring it into Azure Machine Learning and use the algorithms that are there for binary classification to determine and predict whether I might be getting sick. So if you look at the information itself, if I visualize the data, what you'll see here is there's the information that I've been collecting. So I could say something like distance, which shows you some information about it over on the right-hand side. If I wanted to compare distance to steps, you'll notice that they correlate pretty closely, which is what you'd expect. I mean, as you're doing more steps, you're probably following greater distance. The exception being when you're running, you do less steps. When you're walking, you do more steps. But you get a feel for the correlation between those particular data points. Then finding things like weight, there's a bit of a histogram around weight, and things like sleep, there's a histogram around that. Beers tends to, it's kind of marked as the wrong 0 to 5 is where the majority are. There are a few days when I have more than 5 beers, and in fact, there was a day when I had more than 11, so we'll call that an anomaly. And when you look inside the data here, it's about identifying the features, what's important, and once you can identify the features, then you can start to train the model to determine the impact that you want to do. Now, as I was saying before, it picked up, falsely I thought that I was getting a virus after I flew to Las Vegas and ran in the heat. So that made me think that I probably need a couple more data points. One, maybe an app on my phone that polls to check by GPS where I am each day, and then maybe what the temperature is outside in that location. So if I see change in location, if I see moving from country to country, I know I've kind of probably been on a plane. And then if I also see outside temperature of 35, I might have a different effect to outside temperature of 10 degrees or negative degrees. And so then what I've done is I've come down and I've identified my label, which is this trained, which is once I determine my features. So over here, I've identified what's important, and I've labeled virus virus as the thing that I'm trying to predict. And then if I look at it, I've tried a couple of algorithms. So remember in the keynote, Jennifer also talked about this Azure Machine Learning algorithmic cheat sheet. That gives you this idea that in this case, I'm predicting categories between sick or not, and I'm using two-class classification. So I've picked up a couple of algorithms here, a two-class decision jungle and a two-class neural network. I wanted to try the neural network because I generally find that the deep learning approach will come out with the more accurate results. And then I've put both of those into my model down here. And I've taken, this is important. Sorry, this step here is important. When you split your data, it's really important to choose a reasonable amount of data to split. So this is saying take 70% of the data and train the model on it, and then take 30% of the data and test the model on that 30%. And then using stratified split, that's also saying you need positive examples in both sets of data, because it doesn't work very well if all of the places you had a virus are actually in the 30% you're testing and not in the 70% where you're training the model. So that's going to make sure that whatever you're testing against is in both the training set and also in the analysis step as well. A lot of people who try this for the first time and don't do that end up not getting as good a results as they could. So on the left, I've got the two-class neural network. On the right, I've got the two-class boosted decision jungle. And then it runs that against my data, and I can visualize that as well. So this is going to assess both of those. And as you remember, the example moving up towards the top is more about how many false positives you get or how many false negatives. So with the neural network, I've got 4 true positives, 1 false negative, 1 false positive, and 200 true negatives. So that's a pretty good result in regards to accuracy and precision. So the thing that's lacking for me here is over the last 4 years, I haven't been sick that much. So I haven't got that many positive examples to train the model. So this will get better as you get more data and you have more examples that you can run it in against. And then once that's been trained, you can publish it out as a web endpoint, and then you can test against it. So if I run it against this test data over here, it's saying, with all this data input, you said you didn't have a virus. I'm predicting that you don't have a virus with 0.05% confidence. So it's, 99.95% confidence. So what it's really saying is, I can almost guarantee you don't. If I increase my resting heart rate, which is a sign that your body's starting to fight something, so let's say I put my heart rate up to 55, and I test that again with the same data, it's saying, no, still don't have a virus, but I've got less confidence. I'm 58% sure you don't. If I increase it to 56 and test, it's now saying, actually, you do have a virus, and I'm 60% sure that you have that virus. Now, if I say, actually, I had 7 beers, notice it's gone, no, you don't have a virus, and I'm 74% sure you don't, because it knows that when I have those beers, my resting heart rate goes up. So it's not as much as one feature, it's kind of a collection of the different features that train the model and give it the input. And so from that, that's then been published, and I call that every time from my Azure function to test and score my data. And then when that finds anomalies, it then pushes out to me and lets me know, hey, slow down, or take it easy, or I think you're getting sick. So I can actually make adjustments before I overdo it or before I push things too far. The next part from this is the bot interface. So I showed you the Power BI interface where I've got the Power BI data set and the Cortana call. The next part was to kind of publish this out as a bot. So I'll show you that working for a start, and then I can talk to you about how I built that. So the good thing about the bot is I can use natural language to find information out from my data in real time. So I could say something like, how many beers did I have last night? And what that's doing is it's now it's taking the question, it's parsing it through a platform we call LUIS, which is language understanding. The language understanding platform, and then it's parsing that and it's sending it back. Now, the reason it took a little bit of time to get that answer back the first time is I've actually got this running on a free version of Azure Functions, which takes a little bit to boot up the first time through. I think if you went to Azure and Jordan's talk a little earlier, they kind of showed that startup time. If you're productionizing this, you'd put it on a higher instance version and make it work that way. So it says OK, but then I can get kind of tricky. So if you look at that question above it, how many flights of stairs did I climb on average during the week this year? On average, you climbed 20 floors per day. So then I could say, how many flights of stairs did I climb on average on the weekend this year? And it can come back and it can say, OK, on average, you climbed 25 floors per day on the weekend this year. I could say, when was I fittest this year? So when was I fittest this year? Your VO2 max was 65 on Saturday, July the 1st, 2017. So that's the day this year where I've, through my VO2 max, which is the volume of oxygen that you can process through your body, and recovery was the highest. So that's a scale, I don't know what the scale goes on, but that was how I was kind of training myself based on fitness. If I could say, what was my lowest VO2 max this year? Oops. Okay, that's a problem. Now that's interesting, because that means that it's misinterpreted the question. So what I can try and do is actually, I can call LUIS here to see what went wrong. So over here, I'm going to put that question into the address bar, which is what was my lowest VO2 max this year. And if I press enter on that, it's looking for VO2 max and it's looking for lowest. So what it's done is LUIS has correctly identified the question, and it's identified what I'm trying to find. So that means the problem isn't in LUIS. It means that LUIS has looked at the nature of the question, it's broken it down into these entities, and it's parsing those into my function. So the function's actually receiving the right information here. I'm going a little off piece because I'm kind of interested to try and debug this to see what's actually going on. So if you want to bear with me, what we're going to try and do is step that through in the code inside of VS Code here and see what comes out from the LUIS and what the query is that I'm trying to build against the database. So as I mentioned before, I've written the solution inside of Node.js. I haven't used the amazing bot boiler framework that Jordan and Azure were talking about earlier. It's a little bit more JavaScript that I learnt 10 years ago, which could be improved significantly, but it's a start. And so what I'm going to do here is inside of Visual Studio, I'm actually already got a debug window open. And if I come over here, this is the bot framework channel emulator where you can test against your bot. So if I paste that question into here, into my bot, what was my lowest VO2 max this year? I should hit my breakpoint over here inside of my code. And here's my search query. So what I'm actually doing behind the scenes is that I'm taking the natural language, I'm parsing it using LUIS, I'm bringing it back as intents, and then I'm reading those intents and I'm turning it into a OData query that I can call against my document database. And so the query here is top 1 from C, where date logged is this year, so that's correct. Order by, okay, so the problem here is it's saying top 1 star and it's not saying minimum or maximum. So inside my code, I've got an issue which is not interpreting that entity of minimum, of least, I think, and parsing it. So there's a bit of a code problem there that I need to go and fix. But that's, gives you an example of how to actually step through this and to debug it. Sorry, with that diversion. But I could do things like saying, when did you last predict that I was unwell? So this is following another channel. And it's saying, OK, you said you were not sick on the 20th of July. On that day, I predicted you were sick with 82% confidence. So that's kind of going down that path. And then I could expand on that, and I could say, when did you predict I was sick this year? And what that's doing now is it's going to bring back, like using these cards, all the times it predicted that I was sick this year. And it's saying, I predicted you were sick, you said you weren't, or I predicted you were sick and you said you were. So you get that feeling of the information coming back, which is great. To show you a little bit more about LUIS, so how many people went and seen sessions here at NDC where they talked about LUIS? There's a few, not everybody. So what LUIS is doing is it's really making it easy to take natural language and convert it into this idea of entities and intents so that you can then take it from a programming interface to turn it into queries against your database or to turn it into actions that you want to do inside of code. So when you have a look at what I've got over here, this is my dashboard. It's saying this is the endpoints hit per the period. This is the breakdown of the kind of things that I've asked of my data. And what's really good is as soon as you build one of these yourself, you test with a small group of people, as soon as you push it out there to get a broader group of people to test it, a whole bunch of stuff is going to pop up on here that you weren't expecting. People ask questions in heaps of different ways, and they have a lot of different approaches to getting the information out. And so the good thing is that it also provides a suggested utterances where it's learning from what people are asking or how people are asking questions, and it's using that learning to suggest new entities or new intents or new ways of doing things. If we have a look inside of the intents themselves, I've actually only got one inside this model, and that's get Garmin data. And the reason for that is the only thing I actually want to do with this bot is search across my data. I don't want my bot to do anything else rather than search across my data. So everything kind of lands in that. If it doesn't land in that, it lands in none. And the bot can then say, I don't understand your question. Try asking me things like, and then give some examples. When I come into here, this is utterances. So this is things like, what was my resting heart rate last month? This thing on the right here is is amazing. It's called DateTime v2, and it is a built-in entity. So when you come down under your entities, you'll notice that there's a pre-built entity just sitting over here. There's a collection of pre-built entities, which means that someone else has done all the work to determine what last year looks like, what last month looks like, what all of those things in relation to time are. So you don't have to do that work, you can just pick that one up. What I've also done is created this kind of hierarchy for things like active minutes, because active minutes has very active minutes and moderative active minutes, which are two different data sets. Heart rate has resting heart rate, minimum heart rate, and maximum heart rate, because those are kind of my data points. And then as you ask for those different things, it will break those down into those different models. This thing down here is really great. This is feature sets. So what you can do in here is you can actually swap a whole bunch of different exchangeables. So what I'm basically saying here, the word beer is exchangeable with these other words. Now, beer's ale, brews ale. And when you start to put words in here, it starts to suggest other related words that you might like to include as well. So it's smart enough to say, well, maybe you want to consider these other words. And if they're exchangeable, they're purely going to swap them when it sees them. And the reason why this is important is I don't speak Norwegian, but I can say, how many beers did I have in 2017? And for anyone who speaks Norwegian in the room,
hvor mange øl hadde jeg i 2017?
So apparently, according to Google, that is how many beers did I have in 2017. If I was to run that against my LUIS model, so let me come over here and say, put that text in there. There it's saying, it's identifying that word there as the Norwegian word for beer. It's also identifying this word here as count, the how many. So, and then it's knowing about the date and the year. So what that means, it means that if I was to paste that into my bot, my bot understands it and comes back with 411 beers. So although Norwegian isn't supported inside LUIS as a language just yet, you can still gain support by using this approach of putting keywords into the entities that you have if you want to understand the language. The other approach that you can take here is that you can translate the phrase that comes in using a translate service API and then call LUIS in English and have that response come back and then translate it back. So there are different approaches you can take. Right now, LUIS supports a number of languages. Norwegian isn't one of them, but that's kind of a technique to make that work. If I have a look over back into my LUIS example, there's a number of other approaches that you can take. So over here in publish and train and test, when you make changes to your LUIS model, you need to retrain it, and then you can publish it out. And once you publish it out, that endpoint is available inside of your bot or inside of your application. Now, you need to think about what that means in regards to DevOps. There is endpoint slots for staging production, so you can run a different cycle. If you push it out to production, you're basically changing the behavior of your bot in production when you make those kind of published changes. Down here as well, you can enable spell checking, which means that if people mistype, it knows the mistyping and adjusts them and changes it. And you can change the time zone of your endpoint as well. So what does last night mean? Well, you kind of want to have a time zone reference as to last night or as to this week. So that can give you that. And then as you extend that and provide the different models for it, your bot gets smarter and it understands more things and it's able to respond better to the information that you give it. So if I come back through here, I think feature detection. So I think that's pretty much what I wanted to cover off today. I know it's late on a Friday afternoon, and I didn't want to run too long, so I intentionally made sure that I wouldn't do that. But I did also want to take you through the repository. So what I first gave this talk when I was up at NDC in Oslo, and what I did over there was I was still using Azure Search inside that solution. So there is some references to that there, but I've cleaned it up and I've made the code available, and I've also published on this README a step-by-step approach of each of the steps that I came together to put the solution together. So you can actually treat it like a recipe and follow through. And I've included my own sample data out there as well. So if you don't have access to your own wearable device, or if you're not getting with your own data, you can leverage my data. Because I've tried having a reasonable amount of data is important. I've got friends who have just started employing the solution from my code using their Garmin device, where they've had it for 3 or 4 months. And there isn't really enough data there to train the model to get the right feedback for them just yet. But having that, but when they're running it against my trained model, it's still providing some degree of accuracy and some degree of feedback. And what I want to do next with this is actually make this a little bit more universal, so I can get more data sets and training so that it can equate to more people who are starting to use it. I haven't extended it to other wearables just yet, so it really is working off Garmin. But if you've got other wearables and other forms of APIs, you can use that as well as an alternative solution. So with the links, I'm providing some resources here. So that's a link to the GitHub page with the code. There's also a good tutorial on using Azure Search and Cosmos DB with the bot framework at that Azure Search bot site. So if you wanted to step through a tutorial to get started, that can do that. There's the ML cheat sheet that we talked about earlier. The bots, this is the other thing I wanted to show you, botframework.com. That's where you can publish your bots to the different channels. LUIS.ai and the bot boiler, which is the example from Azure and Jordan. So if I show you this last bit here, this is where Microsoft makes it available for you to publish your bots up to dev.botframework.com. And the good thing about this is that this takes care of the hosting and distribution of the different channels you might want to have your bot consume through. So you could add things like Cortana, Slack, a group, Twilio for SMS, Telegram, Teams, as different channels for your bot to interact with. And once you add them, they're published up here as endpoints. So I've got Facebook Messenger running, Skype, Skype for Business, and web chat. If you want to test your bot, you can test it in here. So I could say, what was my lowest heart rate this week? What is that? Oh, I know what's happened. The session's timed out. Sorry. So if I test that, I could say, what was my lowest heart rate this week? And that enables you to test your bot and get your information out inside this channel. So you don't have to worry about the writing for the different chat clients. That's going to be handled for you through this Channel Connect. And then you just need to focus on the workings of the bot and the information that you want to put together for it. So overall, that's my little journey, the experience that I've had. And if you want to reach out to me, you can reach out on Twitter. Really interested to see what people do with this and how others can learn from it as well, because I'm really encouraged by other people coming up to me afterwards saying, hey, I was really inspired by that idea of change and tracking behaviour, and I'm seeing a lot of others pick it up and run with it themselves. So thank you for that, and right on 4 o'clock on a Friday. So thanks a lot, and I hope to enjoy a beer with you at some point. Thank you.